Hi everyone, welcome back. I'm going to be doing another projectile motion problem. So if you want to be stronger than you were at the start of the video, pause at some point and try to make progress towards the final answer. And if you don't, watch the video again later and try again. With that being said, let's go. Firemen are shooting a stream of water at a burning building using a high-pressure hose that shoots out the water with a speed of 25 meters per second as it leaves the end of the hose. Once it leaves the hose, the water moves in projectile motion. The firemen adjust the angle of elevation alpha of the hose until the water takes 3 seconds to reach a building 45 meters away. You can ignore air resistance. Assume that the end of the hose is at ground level. Okay. A. Find the angle of elevation alpha. B. Find the speed and acceleration of the water, the highest point in its trajectory. And C. How high above the ground does the water strike the building, and how fast is it moving just before it hits the building? Okay, a lot of stuff here. So let's draw a picture to start with. Okay, so this here is ground level. This here is the building. These here are the firefighters. I'm going to take this to be my origin. So straight up is going to be the y-axis, and horizontally is going to be the x-axis, like this. It says here that the building is 45 meters away, so this here is 45. Now the hose is at ground level, so and the trajectory of the water is going to look like a parabola, something like this. So the initial velocity vector is going to be up like that, and we don't know what the angle is. It's just alpha. We're gonna have to figure that out, and they tell us how long it takes, so we know that t is 3 seconds. Anything else? 45. Okay, and we have the initial speed v0. The speed is 25 meters per second. Okay. So I'm thinking that we should consider the horizontal motion first, because they give us the final x position and we know what the initial x position is. Actually, let me back up a bit. Let me first start by finding the components of the initial velocity along the y and x axes. So this here is the triangle. The hypotenuse is v0, which is 25 meters per second. Vertically, it's going to be v0y. And the component of the initial velocity along the horizontal is v0x. And the angle here is alpha. Let's start by writing a formula for v0x in terms of alpha and v0, the hypotenuse. So we're going to use we're going to take the cosine of alpha. This is the ratio of the adjacent side, which is v0x over 25. Solving this for v0x gives me 25 cosine alpha. And if I take the sine of alpha instead, this is the ratio of the opposite side, v0y, to the hypotenuse, v0, which is 25. And that means that v0y equals 25 sine alpha. And the reason I'm doing this is because I want to consider the motion in the horizontal direction now. So horizontal. Standard kinematic equation for that is x equals x naught plus v0x t plus 1/2 axt squared. The final x position of the water is going to be 45. Initial x position is 0. v0x, that's going to be 25 cosine alpha. And t is 3 seconds. That's the time it takes to go from the ground all the way to where it strikes the building. So 3. And because this is because we're neglecting air resistance, so there is no acceleration in the x direction. The water does not speed up or slow down as it moves horizontally. So this term here is 0, as is standard in every projectile motion problem in all right, so I have an equation here that involves only alpha, and I can solve for that. So this is 45 equals 3 times 25, 75 cosine alpha. And if I divide both sides by 75, I get cosine alpha equals 45 over 75. Now let's get out the calculator. 45 over 75, that is 3/5. And now I'm going to take the inverse cosine. And this will give me a result in radians, so I want to multiply it by 180 over pi to change it to degrees. So let's see what that decimal is. 53.1. So alpha is approximately 53.1 degrees. Find the angle of elevation alpha. Yeah, so that's the answer for part A. Part B, find the speed and acceleration of the water at the highest point in its trajectory. So the acceleration is the same throughout the motion. Ax is constantly 0. So they're asking at the highest point. So that's at the top of the parabola here. Ax is 0. And Ay is going to be negative g. G is the acceleration due to gravity. That's the only force that acts on the water. And because I define my positive y-axis pointing up and gravity points down, that's why there's a minus sign here. So yeah, this is these are the components of acceleration at the highest point, of the water at the highest point. Now it's also asking for velocity, right? The speed. So at the highest point, there is no, the vertical component of the velocity is 0 because it's at the top of the parabola. The velocity is purely horizontal at this point. And as I said before, ax is 0. The velocity, the speed in the x direction, does not change. So Vx equals V0. It's the same as it was initially. I'm sorry, V0x, I should say. And Vy is 0. So yeah, V0x is 25 cosine alpha, which is 3/5. 25 times cos alpha, which is 25 times 3/5. That's what cosine alpha is. 5 times 3 is 15 meters per second. This is what the horizontal component of the velocity is at the highest point, as well as initially. So these are the answers for part B, and now for part C. How high above the ground does the water strike the building, and how fast is it moving just before? Okay. So just now I was talking about the top of the parabola. For part C and D, I'm going to take the point where the water strikes the building as my final position. What we're looking for is the height, which is y max, as well as the velocity vector v. So these are what we're looking for. Let's go ahead and consider the vertical motion. So vertical, y equals y0 plus v0y t plus 1/2 ay t squared. So y, the final y position is y max. Y0, that's going to be the starting height, which is 0. V0y, that's going to be 25 sine alpha. So sine of alpha, that's going to be 4/5. I just did that in my head because it's basically a 3, 4, 5 triangle like this. So cosine of alpha is 3/5. So sine of alpha is going to be 4/5 because for a right triangle, if this is 3 and this is 5, this has to be 4, and sine of alpha is going to be 4/5. So 25 times 4/5. 5 times 4 is 20. So V0y is going to be 20 meters per second. And then t, and then minus 1/2 gt squared. And that's it. So we know that t is going to be 3 seconds. So let's get out the calculator again. All right, so 20 times 3 minus 1/2, 9.81, times 3, and then squared. 15.9 meters high. And just to check, this here was alpha, right? So let me just go ahead and show you that sine of all of this. Four-fifths, yep, there we go. All right, so finally, the final velocity vector. So the components of the final velocity vector, right before it strikes the building, it's going to have an x component like this. This is Vx. And Vy is going to be like that, pointing straight down. As I said before, there's no acceleration in the x direction, so Vx is going to be V0x, the same as it was initially, and the same as it was at the top of the parabola. V0x is going to be 25 cosine alpha, which is 15 meters per second. And now Vy. So for that, we need to know, we need to use the other kinematic formula, the one that relates final velocity and initial velocity. So V equals V0 plus AT. I'm going to apply this in the y direction. Vy, that's what we're looking for. So equals V0y. That is 20. AY is minus GT. T is 3 seconds, G is 9.81. So let's use the calculator once more. 20 minus 9.81 times 3. Negative 9.43. Let's see, the question is asking for how high above the ground does the water strike, how fast is it moving just before, right, so they want the speed, so that's going to be the magnitude, whoops. That's going to be the magnitude of this final velocity vector. So this here is V, this here is Vy, and this here is Vx. So using the Pythagorean theorem, V squared equals Vx squared plus Vy squared. And so V is the square, V equals the square root of Vx squared plus Vy squared. Vx, that was 15. Squared and plus negative 9.43 squared. Oh, and this is approximate here. All right, so using the calculator once more, I get 15 squared plus negative 9.43 squared. This is the magnitude of the final velocity vector, and that is 17.7 meters per second. And this is our final answer for the last part of this question. How high above the ground? Yep, we got Y max. Y max 15.9 meters, yep. And I believe that's it. All right, thank you everyone for watching. I will see you later.